The measurement of 1 foot is the same as 12 inches. This means there are 12 unit or 1-inch segments inside of a foot. As you can see here, I have a foot length represented, and then each of the 12 1-inch segments cut up into there. And this is going to be important for when we talk about area. We're talking about unit segments, and this is 1 inch, so that's going to be a unit segment. And that's how we count up and know there are 12 inches, because there's going to be 12 1-inch segments. Now, Wally wants to put in some 2 foot by 8 foot raised beds in his backyard. So you can see that here in this diagram. You can see this is the backyard, and we have these 3 raised beds, and they're 2 feet by 8 feet long. He needs to know how much soil to buy, of course, because you have to put soil in the raised beds. And to do that, he, of course, needs to know how much space he must fill. To find that, we're going to cut up the plot into smaller unit plots. So here are the 3 raised beds. We're just taking these 3 raised beds and we're just putting them all together. And then we're going to cut them up into unit plots. Or in other words, we have 2 feet by 8 feet for all of these. So this is going to be 2, 2, 2, and 8 feet long. So I'm going to cut this up into 1 foot long segments. And then I'm going to cut it further into 8 feet segments, the 8 feet into their individual 1 foot segments that way. And we get this representation here. So you can count up how many boxes are in that diagram. And there's going to be 48 1 foot segments. So we have 48 of these 1 by 1 foot segments. They're 1 by 1 because here previously we were talking about 1 inch segments of a foot, which is a length, just a single dimension. And here we're talking about 2 dimensions. We have a 1 foot by 1 foot, and so you can complete the square. We have 2 square dimensions here that we're talking about. Each one of these things are 1 foot by 1 foot, like this. And that's the same thing as saying 1 foot squared. That's what the plots are represented as. That's what the unit plots, the unit segments are represented as. Okay, this is going to be the area of this shape. It's 48 feet squared. You can see that, of course, if it combines into one big plot like we did here, we really just have 6 feet by 8 feet, because it's 6 feet long along the bottom. 2 plus 2 plus 2 is 6, and then 8 feet along the side. And we get 6 times 8 feet times feet is 48 feet times feet, and that gives us 48 feet squared. So we don't actually have to do this cutting it up. We can just multiply the length by the width when they're rectangles. So you can see that here for these 2 shapes here, we have a square here. We can, of course, cut this up into thirds. And the same thing, thirds along the side here. And we count 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 square units here. We're not saying what length they are, but we can still say that there's 9 of them. There's 9 unit segments. This is the same thing as seeing that this is 3 along this direction and 3 along this direction. So 3 times 3 is 9. So that's a way of getting the area simply. Same idea here, right? We can cut this up into unit blocks, the unit segments. Unit squares, I should say. That's what they really are. And we can count them all up, and there's going to be 18 of them. It's the same thing as saying 3 times 6 is 18. And this one does have lengths, right? These are going to be 18 meters squared. So really, I should be saying 18 meters squared. So we're going to have meter times meter. 1 times 1 is 1 squared. 2 times 2 is 2 squared. Meter times meter is meter squared. Now, that's the idea of finding area. You're going to count up these unit segments that we're talking about. But some formulas are going to help us out for general shapes. And you can see here we have a bunch of different formulas for different types of shapes. These are, of course, not all the shapes, but some common ones. And it's important to note here that in most of these things, we're talking about a base and a height, or a length times a width. Either way you want to think about it. What's important to note here is that, for instance, for the square here on the left, we have all the side lengths are the same. They're all the same length. And to find the area of the square, we're going to take the side length base times the side length base. That's like a base times a height. The height happens to be the exact same thing as the base since the square is the same length all the way around it. That gives us an area of b times b, or just b squared. That's actually why it's called b squared, right? Because we're squaring the unit. When you square a unit, you're making a square out of it, and you're just multiplying by itself. Rectangle, you can think of it as base times height. And you can see here the base and the height are 90 degrees from each other. This is an important idea, and you're going to see this for all of these formulas, that the base and the height are 90 degrees, or they're called orthogonal. That's what I have shown written up here, is the word orthogonal. In mathematics, that means at a right angle to each other. It's not just a right angle in 2 dimensions. We're also talking about 3 dimensions, 4 dimensions, and so on. For a triangle, you can see that we have a base and a height, and they're, of course, 90 degrees from each other. The height can be outside of this triangle. You can see that this height here is just the height from to the tallest point from the base, and it's the straight line distance. You're not going to find this would not be the height, because this is a longer. It's not straight down to the base. You have to always go vertically, and it has to be at a 90-degree angle. So a triangle has 1/2 base times height. Trapezoid here, it's important to know both the bases because there's actually 2 bases here for a trapezoid. And really what we're doing here is we're taking an average of the bases and multiplying it by the height of the trapezoid, or the distance between the 2 bases. That's how you find the area of a trapezoid. Parallelogram and rhombus, they're actually the exact same thing as a rectangle. The rectangle is a little bit easier though, because the height is the side length. Whereas the parallelogram and the rhombus, you have to know the height of the shape, because the side length will not give you the correct area measurement if you just multiply the two side lengths together. So you have to know the height for these things to find that area. Okay, let's see this in practice. So the areas of the following shapes. A triangle is this one right here. This is 1/2 base times height. The height here is 7, so the height is 7, and the base is 12. We can see that because they're 90-degree angles from each other, and the base goes all the way across the bottom. The height goes straight up to the highest point. So the area of this triangle, and the area of a triangle, for instance, is 1/2 base times height. I'm just going to plug those numbers into the B and H. And I get 1/2 times 12 is 6. 6 times 7 is 42. And this is in inches and inches. So area is always a square measurement, inch squared. They should always be the same measurement. So it's not going to be feet times inch. That would be an area measurement, but it's incorrect to think about it that way. You want it to be the same unit, inch times inch. So inch squared is how you write that. Okay, here we have meters. We have 4.3 meters and 12.9 meters. This is a parallelogram. Area of parallelogram is base times height. You can see that the base is 12.9 and the height is 4.3. So the area of the parallelogram is base times height, 12.9 times 4.3. It's going to be meter times meter. And let me use a calculator here to find this. I'm getting 55.47 meter times meter is meter squared. So that's going to be the area measurement for this parallelogram. A trapezoid, and the trapezoid is this one right here. It's going to be the average between the bases, right? To find an average, you add up however many numbers you want to average, and then divide by how many there are. There's 2 bases here, so we're going to add the 2 bases, then divide by 2, since we're adding 2 numbers. So the area of this trapezoid, it's kind of hard because I can't just use T. I'm just going to write it as just A, because T stands for triangle as well, right? But the area for the trapezoid is going to be base 1. So we'll say that this one's base 1, this one's base 2. It doesn't really matter which one's base 1 and base 2. And this is definitely the height, right? 8 centimeters is the distance between the 2 bases. So we're going to do base 1 plus base 2 divided by 2 times the height, which is 8. Order of operations, of course, we have to do the fraction stuff first. 10 plus 6 is 16. And then going left to right, 16 over 2 is 8. and 8 times 8 is 64. And here we have centimeter times centimeter, so centimeter squared. When you add the 2 centimeters together, which is the 10 to the 6, you get a single centimeter, right? 2 feet plus 3 feet is 5 feet. You're not multiplying the two things together. It's when you multiply them, that's when you get a unit squared. And here we have centimeters squared, since this is an area measurement. Okay, for this one, we can see that we have actually a compound shape. And what we can do is we can cut this thing up into shapes that we know. First off, I know that there is a triangle here. If I just cut across like this, I can see that I get a triangle there. Now, I can also cut straight down like this, and I can see that I actually have a rectangle here and a rectangle there. So I've got 2 rectangles and a triangle. So the full area is going to be each of these areas and then added up together. So let's find the areas here. If this full length is 6, this is all 6 feet here, and this is 4 feet, that means that this length here must be 2 feet. 6 minus 4 is 2. Okay, and then we know that this is 2 feet here, so we're going to have a 2 by 4. This is a 2 by 4. And this rectangle that's vertical here, let's see, it's this is 2 feet here, and this is also 2 feet here. So in total, this distance here is going to be 4 feet. So we have, again, a 2 by 4 area rectangle. And then this is a triangle, right? The base is 2 feet. The height is 2 feet. Those are 90 degrees from each other. We're going to have to assume that's the case. And to find the area of that triangle, it's going to be 1/2 base times height. 1/2 times 2 is 1, times 2 is 2. So we get 2 feet squared for this triangle. We have 2 times 4 for this rectangle, and 2 times 4 for that rectangle. So it's going to be 8 for both those rectangles. So we have 2 from the triangle. It's going to be 2 feet squared for the triangle, the area. Then 8 feet squared for the first rectangle, and then another 8 feet squared for the second rectangle. In total, we have 18 feet squared for the entire shape. Now, another way of thinking about this is to instead think of this as a parallelogram and a rectangle, right? This parallelogram, you can do the same reasoning, right? This is 2 feet, this is 2 feet here, and this portion here is 2 feet as well. So this whole portion on the side is going to be 6 feet, since it's 2 plus 2 plus 2. And then we can see that this is 2 feet, and this is also 2 feet. So that's going to be 4 feet for that whole base. So the area of a trapezoid, right, it's going to be this formula here is B1 plus B2 divided by 2. So it's going to be 6 plus 4 divided by 2. It'll be 10 divided by 2 is 5. And then the height is going to be 2. The height here would be a 90 degree. It'd be this distance here. The distance between the two bases, that's the height. And this would be 2 feet. So 5 times 2 is 10. And then we have this rectangle here. And this is 2 by 4 still. That's going to be 8. 10 plus 8 is 18 feet squared again. Different ways you can think about the problem is whatever way that makes the most sense to you. Okay, for this one here, we have an interesting shape. And what we want to do is figure out the area of the shaded region. That's going to be this blue region here. So we need to figure out a way of solving this. So first off, I see that this is a rectangle, this white area here, that's 11 by 21. I also see that this right here is a triangle. It's got a 90 degree angle there. If this is 21 here, that's 21, and this full length is 34. And that means that this length here must be, let's see, 21 minus 34 is 13. It's going to be in millimeters. What else do we have? We have, if this full length here is 20 and this length here is 11, that means we know that this length here, let's see, go out like this. This length here must be 9 millimeters. Okay, so I can see a couple ways of thinking about this, right? We can think of this as the full rectangle going all the way around the outside. This is a full rectangle here. And then we can just remove this triangle and this rectangle from that overall large rectangle. We could also think of this as a trapezoid. So the trapezoid would be like this one. And then we remove out from this trapezoid, we just cut this rectangle part out of it. Either way we do this, we should get the same answer. Let's do the trapezoid and remove the square or the rectangle from it. So the overall trapezoid, the bases are going to be always the parallel sides. So that's going to be this side here and this top side here. So this bottom side is 21 millimeters. And the top side is 34. So the area of this full thing is going to be base 1, which we'll do like 21, plus base 2 is 34. And the height is the distance between the two bases. That's going to be 20 millimeters because that's a right angle from each other. So it's going to be times by 20. Let me plug this in a calculator, see what we get. I am getting 550, and it's going to be millimeters squared. But we have to remove this rectangle from that trapezoid. So this rectangle has a height of 11 and a base of 21. So 11 times 21 is 231 millimeters squared. So the total area of the shaded region is going to be 550 minus 231. And that gives 319. So that is the area of that blue shaded region there. All right, how much area of flooring is required for the following rooms? And then what length of edging is needed for the baseboards? So we have 3 rooms here, A, B, and C. And then we also need to figure out what is the length around these portions. We're not going to include the doors because the doors don't have baseboards on them. But we do have baseboards on all of the side lengths for these rooms. So we're going to have to add up. So that's what we're kind of calculating here. The area is going to be the flooring, and the perimeter is the edging for the baseboards. So let's find the area first. We can see here that we have room C is an 8 by 8 square. So we know that area is going to be 8 times 8 feet. We're going to add that to the hallway here, which is B. And that looks to be, let's see, it says 4 feet here. And this full length is 10 feet. So this entire length here is going to be 4 feet and 10 feet, or 14 feet. So it's going to be 3 by 14. And then we have A. A is going to be a 15 by 10 foot rectangle. So the area of a rectangle is just base times height. Okay, that gives us the total area for all of the spaces. And doing this, we get 256, and this is going to be, everything was in feet, so it's going to be feet squared. That's how much carpeting is required to carpet all of this space. Okay, now for the baseboards, we have to consider the perimeter. So we know we have 8 feet here, 8 feet here, 8 feet here, and then only, right, this is going to be 8 feet, and then this is a 2 foot wide doorway. So it's going to be 8 feet minus 2 feet. So this is going to be just 6 feet. So we have 8, 8, 8, and 6. Perimeter is just adding up the side lengths, right? Now, in addition to that, we're going to have this distance here. Well, we already knew that the full distance was 14. That's what we calculated from the area. And we're going to remove off the 2 foot wide doorway. So this distance is just going to be 12. So we have 12 feet there. We have 3 feet here. We have again a 12 feet, right? This full distance is 14, and we're just going to subtract off this doorway. So that's going to be 12 feet again. And then we have 3 feet here. So we have 12, 3, 12, 3. And finally, for this final room, we have 15 feet is this one. We have 10 feet here. We have 15 feet again. And then this, right, this is 10 feet going up. We need to remove the 2 foot wide doorway. 10 minus 2 is 8. So we want 8 feet for just this portion here. So we're going to have 15, 10, 15, and 8. And I'm getting 108. It's going to be a length measurement because we're calculating the perimeter, which is just a length around the shape. So 108 feet is the minimum required for the edging needed for the baseboards. Okay, here we have this landmass, and we are approximating the surface area of this landmass with a rhombus. The area of a rhombus is base times height. And you can see here that because we have a right angle here, we know that this is our height. And a rhombus has all the same side lengths, so this is going to be 363.2, 363.2, 363.2. So we know the base is 363.2 and the height is 249.5. These are both in miles, so the unit is going to be miles squared. That gives us, I'm getting 106,962.4 miles squared.